Today, our topic is factory acceptance test FAT should follow standards or commercial realities. Should factory acceptance test FAT follow technical standards without compromise, or when problems are discovered, the customer and the supplier should make reasonable decisions based on the actual in customized automation projects. One of the most difficult problems, because the biggest risk of FAT is often not a test failure, but making the wrong decision after the test. Common misconception. Many people think that FAT is just a simple pass or fail inspection process. If the equipment passes, it will be shipped, and the project will stop if it fails. But in reality, custom automation projects are rarely so simple. Unlike standard equipment, customized automation systems are developed from scratch. During the FAT process, various unexpected technical and engineering changes, or even changes in customer requirements. The real challenge lies in deciding how these problems should be managed. Technical analysis. Not all problems found in FAT have the same level of risk. In actual projects, most problems can be divided into 5 categories. Some require simple rectifications, such as document and data issues, or some small-scale adjustments. Some problems require additional engineering work, such as POC program mechanical optimization, position adjustment, or process parameter debugging. Some problems involve major changes, redesign, or high-cost hardware modifications. There are also cases where, due to changes in the product or manufacturing process, the originally formulated technical requirements are no longer realistic. Customers sometimes during the FAT propose new and additional functional requirements, which is a project change rather than equipment defects, which should be managed separately. If all problems are handled in the same way, it often leads to wrong project decisions. Where does the real risk start? Many companies choose to are shipped before some SAT issues are solved. Their idea is simple. We will solve all problems during the SAT stage. But the risk starts here. Once the equipment leaves the supplier's factory, the engineering support cost will increase. Communication efficiency will decrease. Project responsibilities often become unclear. For the same technical problem, costs more to solve in the SAT stage is usually much higher than in the FAT stage. Industrial case. I once participated in a project due to the customer's own product was still changing. The customer agreed to ship the equipment with some. He shipped before some FAT issues were fully resolved. The original plan was to complete SAT soon after installation, but the project was finally delayed for nearly 2 years. During this period, the project leader changed. The purchasing staff left. The supplier's original commissioning engineer also left. When SAT was finally restarted, the new engineer had difficulty fully understanding the original POC program logic and equipment design ideas. It required several months of extra work. The production line was finally completed. The technical issues themselves did not change. What changed was the cost of solving the problem. The core summary is that a successful FAT does not reject all problems, nor accepting all compromises. Professional FAT management is to identify which risks must be eliminated before shipment, and which risks can be managed and manage them through a clearly agreed plan. The goal is not to let one party gain the most benefit. The goal is to achieve the long-term success of the entire project. Conclusion. How does your company usually handle difficult FAT decisions? Do you insist that all technical must be met before shipment, or sometimes accept controlled risks to push the project forward? Welcome to share your project experience in the comments.